Welcome to the evidence room. I'm your lead detective, and today we're opening up a very specific, highly volatile case file. When you dive into the Cambridge Mathematics AS and A-level syllabus, specifically paper 9709, it is absolutely wild to see how section 2.2, which covers logarithmic and exponential functions, acts almost like a repeat offender. Seriously, it's like this mathematical suspect shows up at the scene of practically every single exam series. And looking at the forensic data, the examiner reports, it consistently trips up unprepared candidates year after year, cohort after cohort. You see, students often walk into the exam hall heavily armed. They've got their textbook definitions, they've highlighted their notes, they know what a logarithm is on paper. But the actual exam papers, they demand something much more rigorous. They aren't looking for a regurgitation of the facts, they are looking for a flawless chain of evidence. To truly understand this, I want you to imagine two hypothetical agents working this case with us. We'll call them Agent Alex and Agent Sam. Now, Agent Alex is your classic procedural detective. Alex gathers vast, massive mountains of physical evidence, meaning he knows every raw fact, every single formula, every definition. But when it comes time to build a coherent case motive in the exam, he completely lacks the high-level analysis to tie it all together. Then, on the other end of the spectrum, you have Agent Sam. Sam is a fast-acting, high-energy detective who just jumps straight to immediate conclusions. Sam will look at a logarithm question, skip 3 vital forensic algebraic confirmation steps, and completely miss the command word constraints. And guess what? They both lose the marks. Today, we are going to dig into the absolute mechanics of exactly why that happens. We are going straight into the examiner's mind to deconstruct the precise, bulletproof strategies you need to secure a flawless score. We're turning those intimidating examiner reports into your ultimate tactical advantage. Okay, let's look at our investigation brief for today. We are breaking this down into 4 distinct phases. Phase 1 is all about core principles and logic. Phase 2 covers our forensic methodology. Phase 3 is where we really get our hands dirty analyzing examiner evidence. And finally, Phase 4, closing the case.
All right, let's step right into Phase 1, the core principles and logic.
Now listen, the academic benchmarks here demand deep analytical depth rather than superficial breadth. I need you to understand that simply knowing the basic laws, the product law, the quotient law, the power law of logarithms, that is just the absolute bare minimum entry fee. It gets you in the door, but it doesn't solve the case. To decode what examiners are actually hunting for, we have to look at these 3 target cognitive domains. It is not just about knowledge and understanding. Let's bring Agent Alex back into the room. Alex has memorized every single log law. You ask him the power law, he recites it perfectly. But you put Alex in front of an unfamiliar context, say a complex exponential decay model involving a radioactive isotope or a cooling liquid, and he absolutely freezes. He has the knowledge, but the application to an unfamiliar context completely paralyzes him because he hasn't developed the analytical depth to structure his reasoning. And then look at Agent Sam. Sam sees the same decay model, recognizes it's a logarithm question, and just starts frantically crunching numbers without setting up a structured equation. Sam leaps right over the analytical depth domain. Applying these concepts to unfamiliar context requires a very calculated, cold breakdown before your pen even touches the paper to calculate a single number. You have to trace how the expectations scale up from standard data tracking right into deep, critical evaluation. If you just describe what the math is doing, you're going to fail to cross-examination.
That brings us right to Phase 2, the forensic methodology. This is where we build out our procedural mechanics.
And this brilliantly illustrates the ultimate safeguard in your exam toolkit, the method mark strategy. Method marks, which you'll often see denoted as M1 in marking schemes, are absolutely critical. They are awarded for demonstrating the correct mathematical process and a clear logical progression, completely regardless of whether your final answer is right or wrong. Think of method marks as your forensic toolkit. Imagine Alex and Sam sitting at the evidence table right now, arguing over how to present a case to the judge. They're tackling a really nasty hidden quadratic equation that involves exponentials. Alex wants to write out a massive paragraph defining what an exponential is, wasting precious time. Sam just wants to punch numbers into the calculator and write down the final root, bypassing the evidence trail entirely. Neither is right. The true detective method is all about the logical string. If you explicitly write out your substitution, for example, if you literally write down, let y equal e to the power of x, and then you accurately substitute y into the equation, boom, you just secured a method mark. Even if, 2 lines down, your quadratic factorization goes completely awry because you dropped a negative sign, that method mark keeps your case alive. Your written working out proves your mathematical intent. It shows the examiner you knew exactly what crime was being committed and you knew the correct protocol to solve it, even if you tripped over your own shoelaces at the finish line. So let's look at how this methodology builds into a strict, standardized sequence. This is a remarkably effective 5-step protocol that you must mandate for every logarithm problem. Step 1, identify the key elements. What base are you working with? Is it natural log, base 10, base 2? Step 2. Apply the relevant principles. Select the correct law of logarithms to dismantle the equation. Step 3. Execute your analysis with crystal clear working. Step 4. Verify the results. This one is huge. If you solve the equation and end up with a negative value for a logarithms domain, you have to mathematically reject it. You can't just leave it there. And step 5, present it in the appropriate format. Listen to me on this. Skipping a step here is literally like contaminating evidence at a crime scene. If you jump 2 algebraic steps in your head because you think you're saving time, you instantly break the chain of custody. You break the logical reasoning. And once that chain is broken, it becomes incredibly difficult for the examiner to follow your logic string, which means they can't award you those life-saving method marks.
Case file freeze. Before we reveal the ultimate framework to help you clear your upcoming Cambridge sessions, make sure your intelligence feed is highly secure. Take a single second right now to subscribe to Ace the Exams at the handle Ace the Exams and turn on all your notifications. You absolutely do not want to miss our weekly forensic exam updates, whether you are cracking cases at IGCSE, O-levels, or AS and A-levels. All right, tape is rolling again. To cement our sequence, we utilize this problem-solving framework. Deconstruct, solve, and evaluate. It's like the Peel matrix for mathematics. When you first look at a really dense paragraph detailing an exponential growth scenario, your first action must be to deconstruct. Extract the initial value, pull out the rate, identify the exact time constraint. Next, you solve systematically. You set up your equations with proper headings and you execute the math straight down the page, line by line. Do not write horizontally across the margins. It makes you look like a chaotic rookie. Finally, you evaluate. Check for reasonableness. If you calculate an answer that says time equals -5 seconds, does that make any physical sense in the context of a real-world model? Absolutely not. You must cross it out and add a quick, sharp annotation justifying exactly why it's invalid. Anchoring your data to your analysis like this elevates a messy draft into a professional top-band response.
Now, let's step into phase 3, analyzing examiner evidence. We are opening up the vaults and looking at the feedback directly from the source.
I am handing the investigation files over to you for a live forensic check. Imagine we are running a 60-second visual clue scan on a massive pile of failed past papers. What's the highest yielding trend? Looking at the official reports, there are 3 main warnings that repeatedly, consistently destroy high-tier marking bands. We're talking about the counterfeit answers that look right at first glance but fall apart under scrutiny. Warning number 1, answers are often too vague. Specific details are required. In the world of high-level math, vague means you applied a logarithm law, but you skipped the intermediate algebraic step on paper, leaving your logic completely ambiguous to the reader. Warning number 2, students forget to check format and presentation conventions. Ask yourself right now, did the command word ask for exactly 3 significant figures, or did it demand an exact answer using the natural log? Let me tell you, handing over a rounded decimal when an exact mathematical value is explicitly demanded loses the accuracy mark instantly. It's an unforced error. Warning number 3, final answers are not specific to the given context. If the mathematical model is tracking a living population of bacteria, your final answer literally cannot be a fraction of a bacterium. You can't have 0.7 of a cell. You have to round appropriately based on the context. These exact errors act like a fingerprint mismatch that instantly compromises your entire solution.
Let's cross-examine this by looking at how it plays out when comparing descriptive versus evaluative answers. Now, you might be sitting there thinking, wait a minute, this is mathematics, not an English essay. But listen to me. At the A-level standard, your mathematics is your argument. A flawed, shallow, descriptive answer simply dumps a memorized formula onto the page, pushes some numbers around aimlessly, and circles whatever random decimal pops out of the calculator. It has superficial breadth, it completely fails to identify limitations or boundaries. On the other hand, an evaluative argument shows the examiner that you are actively managing the problem. It means you mathematically question assumptions, like recognizing that an exponential decay function never actually reaches 0, it just approaches an asymptote. It means you justify your decisions, explicitly stating why a specific root is mathematically invalid within the given domain of the logarithm. Isolating these discrepancies and communicating at this level is exactly what separates a standard C grade from an elite A grade.
So, the crucial point is this official mandate straight from the Cambridge examiners. Students lose marks by not showing working. Even if your final answer is wrong, method marks can save you. This is your ultimate alibi. It makes it crystal clear that your written working out isn't just some scratchpad math that you do on the side. It is your undeniably documented proof. Every single application of the product law, every use of the quotient law, every time you utilize a change of base formula, it absolutely needs to be written down. You are essentially building a logical, unbreakable chain of evidence from the very first line of ink to the final double underline answer. If you hide your steps, you hide your alibi, and you lose the case.
Finally, we arrive at phase 4. We are synthesizing our data and closing the case.
Distilling all those forensic examiner reports gives us a really powerful, actionable memory hack. I call it the VFC audit. Right before you finish a logarithm question, before you move on to the next page, you run this live forensic check. V stands for vague. Ask yourself, is your working clear, or did you skip algebraic steps? Did you explicitly show the let y equal e to the power of x substitution? F stands for format. Look right back up at the command words in the prompt. Did they ask for 3 decimal places? Did they ask for exact form? If you miss the format constraint, you drop a mark for absolutely no reason. And finally, C stands for context. Did you check for extraneous roots? Do your time or population variables actually make logical sense in the real physical world? Running the VFC check acts as a final audit to adjust your evidence and completely lock down that grade before the clock runs out.
So Agent Alex and Agent Sam have compiled their final high-scoring text blocks, and we've confirmed a 100% case resolution score. The investigation concludes with 3 universal rules: the 3-step question scan for decoding, the clock budget allocation for timing, and the final evidence audit, our VFC checklist for review. I leave you with this critical question: are you leaving a bulletproof trail of evidence in your working? The next time you sit down with a complex Cambridge past paper, ask yourself if a highly critical examiner can follow your logic string without a single solitary doubt. If the answer is no, it is time to audit your methodology. I want you to hit that subscribe button for Ace the Exams at the handle Ace the Exams. Click the notification bell for weekly forensic grade masterclasses. And right now, drop a comment below sharing exactly which Cambridge subject and level, IGCSE, O, AS, or A level, you are preparing to conquer next. Class dismissed. Stay sharp out there.